All right, is this audible? All right, excellent. So as you said, we're Josh and Patrick. We won't belabor a long personal introduction. We work for PSC. We do a lot of PCI stuff, but PCI can mean a lot of things to different people. I think you'll see our perspective on pen testing, and it's fun to apply kind of a high road idea of pen testing, what pen test really ought to be, to the PCI space. So quickly, what is pen testing? After you've been doing it for a couple decades, you start to feel like pen testing is where you hack stuff. That's kind of the intuitive model. The industry wants it to be something more formalized and repeatable, and so we have methodologies that say pen testing is this series of stages or something like that. But unfortunately, sometimes industry wants to take that and distill it into something that's maybe more profitable. So this talk is really not about this kind of pen testing. It's not about do a scan on a few IPs and then give a report and say you look good this year. That's not really a pen test. In real life, or at least conceptually, what a pen test should always have is some sort of objective. There's something that we're trying to achieve. We're trying to answer a compliance question. We're trying to find significant risks, and we're going to do that by demonstrating through some series of techniques that we can gain access to things, we can escalate, we can find our way to the crown jewels, and answer those important questions. So this talk isn't really about 0 days. It's not necessarily about tools. What we're talking about is tactics or strategy. We're talking about the thought process and how do you take the fact that I did Metasploit Unleashed, so I know how to compromise something, but how do you turn that into finding the crown jewels, and especially as networks scale. Most of the hacking classes that we take have little tiny test networks where everything's pretty easy to find. In real life, you might have thousands or hundreds of thousands of systems on a network. How do you, in a couple weeks, find those crown jewels that are scattered somewhere within that humongous space? So we'll go through a number of scenarios illustrating some specific examples, but hopefully trying to focus on the thought process, the technique, general solutions to finding your way through a network and find those crown jewels.
All right, so excuse me. As a pen tester, when we first start our engagements, one of the first things we want to hone in on or start thinking about as we kick it off is what's going to be our low-hanging fruit, or what's going to be our initial access point. And a lot of times it's something that's easy to find, but I think something that we're recognizing now is that we're doing more organizations who have a more mature security program, something where they've been through this process a few times, and they've been able to harden a lot of these gaps, and this low-hanging fruit becomes a little bit harder to find. So as we kick off a pen test also, in these initial stages, one of the things we're doing is sort of a scanning, enumeration. As we start, though, we might not have a real clear picture of what the pen test or what the network environment looks like. And hopefully the driving force behind the enumeration attempts is, can we clear up this picture a little bit? So also as we kick off our pen test, one of the things we're trying to feel for is, actually let's go ahead and jump into, one of the recent pen tests I did was one of these organizations who had a more mature security program. They had probably done pen tests for 5 or 6 years. They had hardened up a lot of these gaps. So one of the things that I look for first, one of the sort of low-hanging fruit approaches is password-based attacks. That can look a lot different depending on what we're really talking about. Is it web services where maybe we can do a little bit of Googling to figure out some common password and usernames. In an Active Directory environment, though, one of the things we're going to hone in on is, can we get a user list? Maybe if we can generate it because we know naming convention, or we can enumerate it from somewhere. In this particular pen test, where the organization had hardened up a lot of those places where I would typically look. So, looking at a wiki, did they have something posted? Did they have an intranet site where I could enumerate users? Could I connect to the DC and cycle them off? No luck. So I wasn't able to find any users, and so at this point I felt like, let's step back and look at what I do know about the environment to see if I can figure out how we can kick this off. And the first thing that I noticed is, looking at DNS names, it looked like quite a few systems were tied to individual users. So we could see that the usernames were related to an individual host. The problem here is yeah, I see that, but I don't know if these are actually usernames. And that is relevant because if I don't know that this fits their naming convention for Active Directory, I don't know if this is going to be a relevant attack. And we want to make sure that we're effective and efficient in anything we're doing. If I'm wasting time running a password-based attack against Active Directory with a bunch of users that don't exist, what did I really accomplish? I just burned a lot of time. So the other thing that I took a look at was remote desktop. Now, this isn't all that special. Everybody's seen remote desktop in a corporate network. What I did notice, though, is if you connect to one of these sessions, if somebody is already there, a lot of times you'll see who that user is. We'll see the domain that they're joined to and the username. So now we can tie these two things together. We can see the naming convention for the domain, and we can see what the users are. Maybe they match exactly. Either way, we can do a little awking and grepping and create a user list for the domain. And what I want to point out here isn't that there's anything special about this. Probably lots of people have followed something similar. My point is, as we're thinking about these initial entry points, a lot of the time the information we need to do them effectively and efficiently is out there. We just have to be willing to look at some uncommon places to find them.
All right, so starting roughly where that leaves off, maybe we didn't find a lot of low-hanging fruit. We weren't able to LLM&R. We didn't find some tomcats and things, but as Patrick described, maybe we found some accidental little information disclosure that gets us that list of usernames. So we try a password. This example, I find that Joe Schmo's password is password1. That's always very popular. And what we find is, in a little network with a few users, you probably won't be so lucky by guessing a password or two. But if you have thousands of users, you'll probably get a lot with just about any password you think to guess. So right now, summer 2016 is real popular. Probably any network of a few thousand users or more is going to have tens of those, very likely, even if they were told not to do it before. So once we get this account, we start thinking, well, what does this account get me? I'm really, really hoping that Joe Schmo is going to be a domain admin, but unfortunately he's not. We find that he's just a member of domain users. And so we let out this little sigh, oh no, I just got this completely useless account. But if we step back for a second and think, I don't have anything else, I don't have any good low-hanging fruit, and this is my first account, do I want to keep going after passwords? Or is there something maybe the domain user gets me that gives me a good actionable path to the next layer of the pen test? So one of the best concepts for pen testing I've run into is one Halvar Flake presented a few years ago called the compromise boundary. And that compromise boundary is the set of things that you control or could control with the information you have. And so even though Joe Schmo is not a domain admin, and maybe not even a local admin anywhere, he's still an interesting user because he's expanded our compromise boundary. We now have access to some things that we wouldn't have had otherwise. We'd like it if he controlled systems, but usually domain user at least has access to lots of files. And some files are more interesting than others. So here are a couple examples of files that have credentials embedded in them. Finding passwords in files isn't the only thing that you might look for. But it turns out that the last 10 years of my pen testing career, this has been probably my highest yield attack technique for escalating from a regular user to a powerful user because nobody ever gets the permissions right on their file shares. The other fun thing about this is you can have a perfect security program, but because file shares are so hard to control, this vulnerability will live forever. All it depends on is somebody creating a new share and putting a file somewhere and not realizing the default permissions are defined in NTFS as everyone read. So on a little network, it's pretty easy to case the file shares. You get 30 users, you might have a few servers, you might have thousands of files to go through. And you can go through that in an afternoon. It doesn't take too much time. But as the network scales, we get to bigger environments. You go to 30,000 users, you're not talking about thousands of files, you're talking about thousands of shares, each of which might have thousands of files. Used to be, when I first started realizing the value of information that people throw into file shares, I just use manual techniques. Go map the directory, look through it with normal clicking around, but it'll probably drive you nuts if you try to do that in a big environment because it's very manual. So then you think, well, let's automate that. We'll find some SMB client, and we'll just do a recursive spider in the file share. But unfortunately, you end up with this situation where file shares often run very deep. And anything that does just your regular depth-first recursive traversal a tree, like a file system, is going to take forever. And you'll end up punting pretty quickly because you've got these 5,000 or 6,000 shares to go through, and the seventh one takes forever. So a number of years ago, I put together a tool I've been carting around for a while called Plunder, which has a couple of features. We do spidering of shares with some business logic built in to make the process make more sense. So one is we limit recursion depth. You don't want to go too deep in the file shares. Another one, you want to ignore errors. And also you want to have configurable target criteria. You want to find the files that are most interesting or most likely to yield something. Anything named web.config is going to be a very interesting file. Once you do this, so you get used to spidering. With this, with the current publicly available Plunder, I can effectively spider a few million files, do a few thousand shares. Works quite well. But you end up with another problem, and that is after I have spidered a bunch of shares, I got over 300 web.config files. So who wants to SMB clients to each one of those, CD into the directories that probably all have spaces in them. So you have to quote them, and it drives you nuts, and you have to more them and see if there's a password in it. Plunder also has a feature that does automatic downloading and mirroring. So the process looks like this. You get a source of information about where shares might be, run them through Plunder to spider the shares, get a list of all files that your user has access to, and then run that list right back into Plunder after you've filtered it out for the ones you're most interested in, and automatically download and mirror them. And then grep gets you your passwords, and this turns a process that's really intractable on a sizable network in a short amount of time into a very straightforward and easy one. I was really hoping that by the time we got to the presentation here that I'd have Plunder 2 available. It's just not quite completely user-friendly yet. Like, I can use it. I've gotten some good success out of it, but it's not quite publishable. But there's some enhancements that I've got in Plunder 2 that should be hitting soon once I release it. And this is, instead of doing depth-first spidering, do breadth-first spidering. Because you want as much information about as many systems as possible as soon as you can. You don't want to get bogged down into the batch processing server that has literally millions of files in a directory tree. And do a couple other things like 100% retention of spidering data, ability to scale up to millions of files. I've indexed up to, I think the last one I used it on was like 18 million files in probably 3 hours, something like that. It really isn't so bad when you think about what it takes to click through it. And then also more complex identification of your target criteria. So look for that if you're interested. I've only been to 3 environments in the last 10 years that I know of where I didn't find something cool on a file share that was not supposed to be there. So it's another one of those infinite vulnerabilities that will never go away.
Right. So, like Josh mentioned at the beginning, one of the things that we tend to focus on is PCI pen testing, but I think we expand that out to thinking of it as goal-based penetration testing because we look at some different scenarios. And one of the things that they have in common, or the way we approach it that they have in common, is what we typically expect is that there is an area of high security where you put all the things that really matter, and you have your area of low security where you put all your users maybe. And obviously they can be separated out lots of different ways. But there's going to be some sort of boundary between these that could be implemented lots of different ways, but typically this is going to be some sort of segmentation boundary, network segmentation boundary that is. But the reality is that the complexities of managing an environment, once you get something that looks like this, means that, that there can be some problems. We know for a fact that they're going to have to access this high security environment to administer it. They're giving users access for different reasons. So something that starts off looking like this over time ends up looking a little bit more like this. And so this is relevant because we know as pen testers, when we approach the pen test, we assume there is a hole somewhere. Our job is we have to make sure we can find it. So let's talk about a situation, or one of the first times I ran into this and had to sort of think through the process on a pen test. So I think the scenario probably mimics what would be common in a lot of situations. Did the initial scanning enumeration, found a web application that was poorly secured, was able to get a shell, find a local administrator account that was common in a group, use that to find some DA creds, great, but that's pretty meaningless unless I went after those DA creds for a very specific reason. I want to use them to do something. So I just have DA creds that doesn't really do anything for me. I want to make sure I turn them into something. So the question becomes, how do I use DA creds to give me access to this high security environment? So I think we go back to the initial assumption, that is, there's holes in this network. We just have to ask the right question to help us to detect them. So thinking about going to that, what's the question? Well, for me is, are there any direct connections from these low security hosts that I already have access to the high security hosts that I don't have access to yet? And if I'm thinking about an individual system and the network connections that it has live, the first thing that pops in my head is NetStat. That's a great way to see what's going on in any given environment. So in this situation, there's probably lots of ways that you could go about collecting a bunch of NetStats, right? You could use PowerShell. Maybe you have Meterpreter open on a lot of different hosts. I'm sure you guys probably could think of some creative ways to go about this. In this particular situation, I just use WinExe and a bash loop to grab all the data. So now I have NetStat data from a whole lot of systems. What's the first thing I want to do? Maybe just run grep. So if I know what my high security networks look like, I can just check to see, are any of these IPs present? Now, unfortunately, in this situation, in the first time I ran through this in a pen test, this didn't pan out. I didn't find any of these direct connections. I've found since then that this is actually fairly common, that this will get you something. This will help you find one of those places. So I had to kind of take this to the next level, which was, what do I do now that I know there are no direct connections, or at least none that I was able to find? And the answer for me was a reference to Josh a little bit when we sort of talked through what some ways we could do something else with this data, was visualize it to come up with finding some patterns that may be a little bit less obvious in the network. Maybe it would tell me something that I didn't already know about what's going on. So Josh just came up with a little script that will parse through the NetStat data and turn it into a Graphviz dot file. With that dot file in hand, we can create a picture of network connections given a specific port. So why is this relevant, or how does this help us? There's lots of ways, there's lots of patterns that you might look for that are relevant. If we see lots of connections coming in and out of an individual host, maybe that means it's something significant like a file server or a database, depending on the port. But I think the most interesting thing, or the thing that matters the most in this situation, is those hosts that the IT team or the network team either can't tell you about because they don't know, or they don't want to tell you about. So what you might do is apply this, look to see, is there a host here that I didn't already know about based on previous enumeration? Can I look for something unique or individual here? And in this pen test, the situation was, there was an old Bastion host that a small group of users was connecting to over RDP, that was connecting to a production VLAN that everyone conveniently forgot about. So once I was able to find that, I already have credit for the environment, and now I've got the access I'm looking for.
Yeah, it's worth pointing out, just like Patrick's saying, a lot of times it's not malice, it's that IT is so complex, and networks grow the way they do kind of naturally. They accrete complexity. And so sometimes looking empirically at how systems are actually talking, you find legacy things no one knew was there. You find systems that are talking directly to databases in places they shouldn't. I didn't know that guy had that spreadsheet with built-in credentials for Oracle. It's really, really interesting when you start data mining this type of information. So next scenario is a little bit different. Instead of being a PCI scenario where we're trying to get into a cardholder data environment and get all the credit card numbers, I was working with a company that's concerned about product leaks. Specifically, they had some situations where someone had leaked information about products. And it was a very interesting scenario. And actually, it's fun talking through what the actual damage of a product leak is. Because it affects things like the timing of product releases. It might affect your old product when people know the new one is coming out. All kinds of really interesting things. So the objective in this case was to find the marketing assets for unreleased products. They were interested to know how hard is it for somebody to find this information about new products if they started poking around in the network. So I don't know about you, but for myself, I tend to overly romanticize what I do. And so I like to think of network as some sort of medieval kingdom. And I figured if I could get the keys to the kingdom in this network, then I could probably find myself haplessly in any random burg and find out what people are doing there, and eventually find the folks who create this content and successfully obtain and then potentially exfiltrate this new product marketing information. The problem was I made it there, I became the king, I had domain admin, and yet I still couldn't find anything. And I'm getting to the end of the pen testing period and thinking, this is kind of a soft environment. I escalated very easily, but man, finding that information is kind of hard. I don't really know what I'm looking for. And so I'm kind of casting about, trying every random little thing I can think of. Heart rate's going up, I'm living in bullet time. And I start going back over all the notes, all the things I had collected as I was doing my scanning and escalation. And one of the quirky things I had enumerated at one point, I had taken a snapshot of all the running services on a whole bunch of machines, and everything in the domain. And I think at the time I was casing them for defensive suites, trying to figure out, what AV are they running or something like that. And it had been essentially uninteresting. But I started looking at the data and I thought, I bet people who create marketing content, maybe they're making 3D models for stuff, they're doing graphics, they're doing stuff, maybe they have interesting software that other people don't have. And since I have this information, I thought I'd start poking into it, do a little bit of data mining. And so what I ended up doing was generating a little visualization showing how commonly each of the services that I had found in those files occurs. So it's really uninteresting. If you look down at the lower left tail here, there are a lot of services that run on every computer. LSASS is running on every computer, for example, the browser service, workstation service, et cetera. So obviously that's not going to help me discriminate specific and interesting targets. On the other end of the spectrum, on the top right, I'm getting it backwards. It's the top right that is running on all the machines. If we look at the left, we have some services that run on only a single box. And that's just going to be the guy that has the Radeon instead of the NVIDIA. Or it's too discriminating. And I thought, I bet the group of people that I'm looking for is a team. It's probably a handful of people. And so I start thinking, anything that shows up in about the team size set of systems might indicate that this is a group of boxes that are a little bit unique or interesting. So as I go through, I looked at everything that has, I think, between 10 and 20 instances across the domain, and I found the SolidWorks licensing service. Anybody know what SolidWorks is? If you're a 3D printer, or if you ever worked for an engineering shop or something, you probably know what it is. SolidWorks is a 3D CAD solution. It's a very nice one. It's very expensive. I wish I could have a copy, but it's quite expensive. And I thought, well, there you go. People that are running CAD packages, they're probably making product data. Maybe they're doing 3D models for the new things or whatever. So I have this list of 12 boxes that are all CAD people. And of course, these people turn out to be the CAD designers. And the CAD designers do something tricky that I had not really thought of. And that was I had plundered the tar out of all the file shares and never found their stuff because they store it on their local desktops and they don't use the shares. I usually exclude $C shares because usually they're not all that interesting when I'm spidering. But once I had those, that's the new product information, and I have my success criteria. What was fun about this, part of it was the joy of just problem solving during a pen test and figuring this thing out. But really, it has become a general strategy that I use in a lot of situations. Fundamentally, there are many cases where you don't know what the next step is in the pen test. So how do you start generating some potential that you'll find that next layer? And so there are a lot of situations where if I can identify some data, some information, if I could have that information about the whole environment, maybe that would lead me somewhere, or just help me figure out which groups are interesting. Then if there's some way I can collect that, usually it involves building a little ad hoc scanner or something. Coding skills are a plus. And then once I get that data, find some way to visualize or mine the data and figure out how can I winnow this down. If I've got 40,000 users worth of information, just looking at it in less is going to take forever. And then of course, once you find the interesting thing, you profit. So you just start thinking of crazy things like, what if I had a list of the network configuration of every adapter on all systems in the domain? You find people that have a secondary interface that's on a special VLAN. You find people that have virtual interfaces and they're connecting to VPNs or something, those people become suddenly very interesting. So if I can just get that data, this may help me discriminate useful targets. If I get a process listing from every system, what can a process listing do for me? Yeah, well, finding interesting software, especially once I know how they're connecting to interesting target areas in the network. Looking at specific files or directories, whether they exist or not. Like if you see this, someone probably has Cisco AnyConnect installed. So out of the 30,000 users, the 129 of them that have Cisco AnyConnect, they're more likely to be connecting to my target zone. So this is a generally applicable strategy to find a massive data, mine it, and use that to lead you to the next interesting thing. So this one we don't trade. Scenario 5 is a little bit different. Title of this one, there will never be a CVE for this because there are some things that as a pen tester, as Patrick said earlier, as the environment gets more mature in their security practices and they have better defensive tools and less low-hanging fruit, they incorporate security early on and so they don't build stuff that's bad. You can't really rely on having useful exploits, existing exploit code out there. But there are a lot of things that work as an attacker that you could never actually make a CVE for because there's never going to be a patch. And no one's ever going to admit responsibility. So in this situation, imagine a scenario where someone has their PCI cardholder data environment. And in order to access it, they use Secure ID or Duo or one of these other multi-factor solutions. And that makes it very difficult. I have the whole domain. I have domain admin. I have all the passwords. But I don't have these tokens or the mobile devices or whatever they're using to do that second factor. And so I'm actually somewhat effectively stopped. There was a time when I would kind of just go, they have MFA, I guess you win. But it turns out MFA can be attacked. There are a lot of interesting bypasses. Did present a few of these a couple years ago at DerbyCon. I'm not going to talk about a bypass in this sense. It's not going to be exactly the same kind of thing. I'm going to talk about something that has actually become the first thing I try every time I see multi-factor in remote desktop. And in order to set up this story, I have to introduce you to Bob. So Bob is your standard everyday Mark I regular user. Bob lives in the Cube farm and ekes out his day doing whatever his regular tasks are. And generally, it's not so bad, except that Bob is ruled by a harsh and unforgiving task mistress. And that is his Outlook calendar. Now, his Outlook calendar never actually looks like this. It's filled up with all kinds of inane meetings that take up inordinate amounts of time. But it's not all bad because he gets to go eat every once in a while. And then you got these moments on the social calendar where you got to get out and talk to the coworkers and find out what's going on, get the scuttlebutt. And then, of course, there's the biological imperative to occasionally hit the restroom. I was having trouble when I made it making a smaller slice and still fitting the font in there. So Bob takes a half hour for bathroom. But what it comes down to is that from Bob's perspective, if it wasn't for all of these intrusions on his calendar, he could really get some work done. And the fact is, most of the time in the workday, his computer looks like this. And this we usually would think of as a security feature, but actually what's behind this screen is a currently logged in multi-factor authenticated remote desktop session in the CDE. If I can only peel this back and get to that session, I could just start clicking on it myself. So I start thinking to myself, I'm going to wait until Bob connects the CDE. And then I'm going to wait for him to lock his screen. I can use Mimikatz to get his password or crack it from the domain or whatever I want to do. I'm going to RDP into his workstation and then use his remote desktop session into the CDE. Find some persistence vector, set up some ICMP shell, or I'll find that I can talk out to something or maybe out to the public internet, whatever it takes. And once I have that, I never have to beat multi-factor again, and I have continuous access into the target zone. So this is something that you can kind of do pretty easily with a lot of existing tools on a small network. You got a relatively small number of employees. A few of them are going to be connecting to this highly secured zone. So I can probably park Mimikatz or something, not Mimikatz, sorry, Meterpreter or something on their boxes and watch for those scenarios. But it gets a lot harder when you scale the network up. You might have hundreds of people who are connecting to this zone, or in some places, think of like call centers and stuff. You could have thousands of people. And what's interesting is on the small side, it doesn't happen very often. It's a tough timing attack. You could wait a whole week and never actually have that scenario, because some people are very fastidious about locking their screens, or logging out before they get up, or other things. But there's this curious thing that happens with scale, and that is that the number of people who might be in this situation goes up. And so the odds that at any given time there's somebody who has an active session in the CDE and that screen hasn't locked, they have locked their desktop and they've walked away. That actually happens quite often in a sizable network. And so this strangely becomes one of the most reliable ways to get into the CDE. Look for these. You just have to have a big enough company. So the big question is, on the large scale, how do I find people with locked screens? If you Google search for that, Stack Overflow will tell you that, hey, maybe there's this Win32 API call, and so I can make an executable and I can throw that out to all the machines. And that's hard. And not that I'm afraid of writing code, but I'm going to do things the easy way if I can. And I found it's just pretty easy to look for logonui.exe. Remember I said, think about what if I knew the processes running on all the systems in the domain? Well, logonui.exe indicates that the screen is locked. So if I can correlate information, Patrick talked about how I find out when they connect to the CDE. I can look at their netstat. And now with this, I can look and see when their screen is locked. So I find connections to target zone by netstat whispering, find people with their screen locked. I can use the super elite hacking tool called grep to compare the two lists, find the intersection, and use a regular remote desktop session to connect. So what it comes down to is I can write a short script that at any given time pumps out a list of IPs that meet these criteria. Big enough network, there's always an IP in the list. So there are a couple things to think about. Probably the biggest objection that I get most often, especially if I talk it through with a customer, is they'll say, yeah, but Baby Bear might come back and find that somebody's been sleeping in his bed, raise the alarm, and how could that really be a useful attack? And that's fair. If you came back to your desk and you saw Remote Desktop had extra windows in it, or you see this big PowerShell one-liner that I was in the middle of typing in the run dialog, that'd probably freak you out. But it turns out it's actually a non-issue, because the first thing that I saw when I logged into his Remote Desktop session was his calendar, and I can see that he's going to be stuck in that change control meeting for a solid hour. And man, if you can't find a persistence vector in an hour, then you have no business trying to do this type of attack. So really, this turns out to be so dumb, I can't believe it actually works. But because most environments are not just 5 people using their computers, it's usually going to be hundreds or thousands or tens of thousands of people. It means that we can play the numbers, and we'll always find these types of situations if I can just figure out a way to detect them.
All right. So this last situation really kind of focuses in on looking for the target data. So you might have a full compromise and have lots of great shells, but unless you've looked and found the data that really matters to the customer, what have you really accomplished? So in this engagement, I had effective full compromise of the corporate, and this was a PCI pen test, so the cardholder data networks. I had domain admin everywhere, I had shells everywhere, but I had become frustrated because I hadn't actually found any large caches of the data I was hunting for. I looked at databases, but I didn't feel good about what the results of the pen test were at that point. So like I said, I have in the process of creating or of going through the exploitation, I had opened up quite a few interpreter shells, and I thought, well, maybe there's some data that would point me in the right direction I just haven't thought about yet. So I started thinking about, okay, who are the users who actually access this data? Because I know somebody's using the data, I know somebody's accessing it. Who are they? What groups might they be in? Is there some way I can distinguish one from the other? So I started looking at one of the first things I grabbed was a list of users and their group memberships. I like to use the GNOME for Linux tool just because I like the handy tool. It's pretty easy to grep through. So look for who's a member of what groups, and then kind of extending on Josh's idea, looking for the processes that they might have. So at this point, it's just kind of manual, right? I look at the user, or maybe look at the groups, and I'm kind of picking at random or looking for groups that might be interesting. But this was an exceptionally large network, so I wasn't having a lot of success. But just kind of picking these things together and trying to correlate, something useful out of it. So, like any good pen tester, I decided to write some code. And the idea was to start by creating nested JSON objects that let me see what the users were members of which groups, and then being able to connect that to the processes they were running based on what I could see from the netset or from the task list output. And excuse me. Unfortunately, this tool isn't ready for public consumption yet. My goal is to have it ready by the end of August. But I'll set the publish date, and so just follow me on Twitter or something. Shameless plug. So the idea here was I wanted to find a way to automate this process a little bit and actually find some useful data. And so what I did is applied a clustering algorithm to those nested JSON objects to see where they're distinct groups, something that tied them together by process, by user group, something that helped me identify, who were the actual unique groups, not just by Active Directory membership. And so what I was able to do by applying these clustering algorithms was turn something that was a little more vague into something that was very specific. So I was able to break down users, what they were doing, what kind of tasks they were running. And the thing that was maybe kind of elusive about it initially was some of these processes are kind of generic. Everybody in the organization, except for customer service, is running Chrome. I see that there's one group of people who also have Chrome and Internet Explorer open. So maybe this is what they're using to access an application in their high security network or the CDE, the cardholder data network. And based on the recommendation of one of my coworkers, I grabbed CC Search, which will pull down, will help me look for credit card data and run it against the temporary internet files of Internet Explorer. And boom, every single one of these users has quite a bit of information that's relevant to my pen test. And now I feel like I've done something successful. It turns out I probably didn't even need to access their high security network because all the data is sitting right there in their low security network in the first place. So now I don't have to ask the question of what's the actual profitable path for this pen test. So I think what Josh and I, when we first started talking about what we were going to do with this talk for the presentation was try to apply something tactically, our tactical mindset when we approach these security problems that are keeping us from getting the data we want, and actually attaching them to some practical process for bypassing these security flaws that we hope that you can actually walk away with something useful from.
I'll also add, in conclusion, some of this, if you think about it, I think Verizon just published another update to the data breach, but I know the last one I had read from them said that your typical intruder resides in your network for something like 8 months. I think the average. If anybody knows a better, more precise figure, let me know. But as a pen tester, I don't have the luxury to just start combing through the environment one little bit at a time. And so sometimes when we're trying to do a good job pen testing for a customer, we're trying to make a safe, marketable, professional process help us understand the other process that it takes 8 months and would cost too much if we could do that. And so sometimes we have to come up with a solution, a technique for finding that information much faster. So a lot of this is about efficiency, but also sometimes a lot of it is about building up an empirical model of the environment so that we can see things that IT doesn't see because they thought they built it right. So anyway, with that, I think we have a little bit of time for questions. Feel free.